Hello, I am Jae Yeon Kim, a student at Won-Hyung University Graduate School of Advanced Imaging Science, Multimedia and Film, who will be in charge of presentation today. From now on, we will start presenting paper using SRGAN in classical games. We will proceed in the order of introduction, background, experimental result, and consideration and conclusion. As you can see on this chart, many 3D games are being produced with the development of 3D technology. However, there is still a demand for classical games. In addition, classical games that embody the main characteristics of classical games, such as dot graphic, by utilizing the sensibility of the best as shown in the picture, are also steadily being released. And like the games in Table 1, game companies in classical games are working on raising graphics to high resolution according to the demand for classical games. Table 1 is video game production companies' remaster game list. However, these high-resolution upgrades are costly, financially, and time-consuming. Therefore, this paper proposes a method of increasing the graphic resolution of classical games and maintaining the texture expression using SRGAN. First is GAN. GAN consists of generator and discriminator competing with each other to generate data. The constructor aims to generate data as similar as possible to the input data. In the case of discriminator, the purpose is to correctly distinguish between the generated data and the actual sample data. Therefore, the constructor must create high-quality images that are difficult for discriminator to distinguish from sample data. The purpose of GAN is to continuously improve performance while confronting each other. This equation is the objective function of GAN, which means finding argument D, discriminator, and argument G is the generator. First of all, in the case of D, both log dx and log 1 minus dgz are maximized to train real data to classify fake data as fake. G also finds a value that minimizes log 1 minus dgz to minimize the total function value and maximize dgz at the same time. Therefore, the discriminator D is trained using the objective function of these two terms. Next is SRGAN. Since it consists of a GAN structure, generator and discriminator are used. The goal of SRGAN is to generate high-resolution image from the input low-resolution image. For this, the artificial neural network of SRGAN must be trained first. Learning consists of a single network, and it is produced at a single network by connecting the generator neural network and the discriminator neural network. In the generator neural network, the original HR image is high resolution image, and the generated SR image, super resolution image, are compared just in the learning process. In learning, the final loss value is calculated by adding the adversarial loss value calculated by the discriminator neural network and the contents loss value generated by the independent VGG at a certain ratio. A function to find the loss of SRGAN. In the above equation, G denotes a generator that receives a low definition image LR and generates a high definition image SR. When the super resolution image I is super resolution image, high resolution image, comes out through the generator. The final loss value is calculated by substituting the content loss equation 4 and the adversarial loss equation 5, respectively, through equation 3. Python 3.6 and PyTorch to train the network used at the time of the experiment, and all networks were trained using table 2 as hardware. CPU is AMD Ryzen 7 2700X. Graphic card is NVIDIA GeForce RTX 2060 3GB. And the test images use the game capture screen of Jump Superstar Dragon Ball stage of Nintendo DS and the character of Dragon Ball Z Budokai FoCoS.IDIC 3 of PlayStation 2. After reducing the pixel of the original high-definition image of the classic game to quarter size, a low-definition image was generated or used as an input of SRGAN. A is the bicubic interpolation, and B is fake image from G, f of 1. C is the result of fake image from G, f of 50, and the D is fake image from G, FoCoS 100. Comparing and checking the images of A and B, you can see the difference in resolution and texture between the image generated simply using interpolation and the game graphic image D after 100 epoch through to SRGAN. Conclusion. In this paper, an experiment was conducted to improve the resolution of classical game graphic using SRGAN. As a result of the experiment, SRGAN showed better result than other technique. This advantage will give the user a higher sense of immersion in the game. It will also reduce the cost of upgrading to exciting high resolution, and it will be used as an area such as DLC that makes good use of the characteristics of classical game. However, the physical limitation of the proposed technique is that it is difficult to apply the technique if the conditions are not satisfied, because high performance computing power is required to process data. As a future research task, a method improving resolution in gameplay in real time through shortening, optimization, and automation of the data pre-processing, pre-process, and calculation process as a whole can be a future task. Thank you.